Hello, you're welcome to this lesson. In this video, you're going to solve this question I have on the screen. The question says, find all nth roots and then write the answers in polar form given that n is equal to 4. So let's look at how you are going to solve this question. So in complex numbers, assume that you have a complex number z and you're supposed to find the nth root of this complex number. You can write this as the nth root of z, okay, and this will be equal to the nth root of the modulus of the given complex number, which I write as r, okay, multiplying e to the power theta, okay, plus 2 pi k, all divided by n, okay, multiplying I, where this k is equal to 0, 1, 2, all the way to n minus 1. So if you are to find the nth root of any given complex number, this is the formula that you are going to use. So I can further rewrite this formula as the nth root of z will be equal to the nth root of the modulus, okay, multiplying cosine of a, okay, plus I sine of a, okay. I can write it as this, where the a, okay, will be equal to theta plus 2 pi k over n, okay. This is what you are going to have. If you are solving this in degrees, then you are going to have a, okay, to be equal to theta plus 360k divided by n. This is for radians, and then this is for degrees. Okay, so with this understanding, let's go back to the question and then solve it. Okay, so we have the complex number to be minus 3 root 3 minus 3i. So let's find the fourth root of this complex number, okay. So that would be something like this, the fourth root of this complex number. So the first thing I'll have to find is the r, which is the modulus, okay. So this will be equal to the square root of 3 root 3 squared, okay, plus 3 squared, okay. So let's simplify this and see what you get for r. So we have the square root of 3 root 3 squared, okay, plus 3 squared. So this will give me a value of 6. So we have our modulus to be 6. So now let's find the argument, which is what? Theta. Okay, so to find the argument, okay, first of all, let's plot the given complex number. Okay, so I have it with this. This is my real axis, and then this is my imaginary axis. So in plotting this, you know that this is going to be negative. I'm going to have positive here, and I'll have positive and then negative here. So if I'm plotting this, I'm going to plot minus 3 root 3 here. Okay, so I'm going to have 3 root 3 here, and then the minus 3 will be here, right? So I have the minus 3 here. Okay, so our argument, okay, will be measured from the real axis here to where the plot is. Okay, so that will be our argument. So our argument will be this whole angle. Okay, so that will be what? Our theta. So that's what you want to find. Okay, so for theta, okay, that will be equal to pi, okay, plus the tan inverse of 3 over 3 root 3. Okay, let me explain this. Okay, so the pi here actually means 180, right? Because you know pi in degrees is 180, and I got this as a result of this 90 degrees here plus this 90 degrees, and that gives us 180, and 180 in radians is what? Pi. That's how come I have pi there, because you want this angle here, that's from the positive real axis, right, to where the plot is. Okay, so now let's talk about the tan inverse of 3 over 3 root 3. Okay, so let's focus on this side here, this side. So let's say I have this small angle here, okay, which I'll name as angle A. Okay, let me use another variable rather, which I'll name as angle B. Okay, so for this angle, I can say that the tan of angle B, okay, will be equal to opposite, right, which is the minus 3, right, over the adjacent, which will be minus 3 root 3, right. Okay, so the negatives will cancel out. You're going to have B, okay, to be equal to the tan inverse of 3 over 3 root 3. Okay, so that's what I have here. So this will be like theta plus B, right, because B is what? Tan inverse of what? 3 over 3 root 3. So that's how come I got that expression there. Okay, so now let's continue. So in finding our theta, we're going to get theta to be equal to 7 over 6 pi. Okay, so now we know our modulus r, which is 6, and then we know our argument theta, which is what? 7 over 6 pi. So now let's go ahead and then find all the roots. Okay, so for the first root, okay, we're going to have k to be 0, right? So we're going to have z0, okay, and then this will be equal to the fourth root of 6, okay, multiplying e to the power theta, right, which is now 7 over 6 pi, okay, plus 2 pi multiplying k, and k is 0 in this case. All this will be divided by n, which is what? 4. And then I'll have my I here. Okay, so let's simplify this. So I'm going to have the fourth root of 6, okay, multiplying e to the power. For the term we have in the bracket, all this will become 0. So then we are going to have 7 pi over 6 divided by 4. So let's look at that. So 7 over 6 pi, okay, divided by 4 will give us 7 over 24 pi. Then let's bring our I. So writing this in polar form, we are going to have the fourth root of 6, okay, multiplying cosine of 7 over 24 pi, okay, plus I sine of 7 over 24 pi. Okay, so this will be the first root. So we have 3 more to find. So let's go ahead. So for the second one, we're going to have the fourth root of 6, okay, multiplying e to the power 7 over 6 pi, okay, plus 2 pi. In this case, k will be 1, okay, and then all this will be divided by 4. Let's bring our I. So let's simplify this and see what you're going to get. You're going to get the fourth root of 6 multiplying e to the power. So in this case, you're going to have 7 over 6, okay, plus 2 pi, and then all will be divided by 4. Okay, so this will give us 19 over 24 pi, and then let's bring our I. So writing this in polar form, you're going to have the fourth root of 6, okay, multiplying the cosine of 19 on 24 pi, right, okay, plus I sine of 19 on 24 pi. So that will be for the second root. So let's find the third and then the fourth. So we're going to have z2 to be equal to the fourth root of 6 multiplying e to the power 7 over 6 pi, okay, 7 over 6 pi plus 2 pi. In this case, k will be 2, okay, and then all will be divided by 4. Let's not forget the I. So let's simplify this and see what you're going to get. Okay, so you're going to have 7 over 6 plus 4 pi, okay, all being divided by 4. So this will give us a value of 31 over 24 pi, okay. Let's bring our I. So writing this in polar form, we're going to get Z2 to be equal to the fourth root of 6, okay. And then you have bracket open cosine of 31 over 24 pi, okay, plus I sine of 31 over 24 pi. Okay, so that will be for the third root. So let's find for the fourth root. So don't forget to always express your answers in polar form, because the question told us to express the answers in polar form. So that's why I leave it at this point. Okay, so now for the fourth root, you're going to have Z3, okay, where K is 3. So you're going to have the fourth root of 6 multiplying e to the power 7 over 6 pi plus 2 pi, okay, multiplying 3 because K is 3, right, all divided by 4, right, okay, and then multiply by I. So let's simplify this and see what you're going to get. You get a fourth root of 6 multiplying e to the power 7 over 6 plus 6 pi divided by 4, and this will give us a value of 43 over 24 pi, and then our I. Okay, so writing this in polar form, I'm going to get the fourth root of 6, okay, multiplying cosine of 43 divided by 24 pi, okay, plus I sine of 43 divided by 24 pi.